subtracted from the rest and still lead to a full area, exactly the same area as the actual face. Now that we have the full area, we can calculate the B1, the first barycentric coordinate, as the area 1 divided by full area. The second barycentric coordinate, the area 2 divided by the full area, and the third barycentric coordinate, area 3 divided by the full area, and the result of the function is going to be a point 3 value containing B1, B2, and B3. Now, we could try to call this function, passing the area 51 mesh as the mesh parameter, the first face, first and only face of that mesh, and the position of the object, a 0.04, as the point in question. We already have the barycentric coordinates displayed on screen, and after evaluating and calling our own function, the result of our getBaryCoords function is identical with the results from the mesh op getBaryCoords function that we use to display the text on screen. Just to be sure, we can call the actual mesh op getBaryCoords function with the same parameters, and the result is identical. Obviously, we don't have to use the getBaryCoords MaxScript function we just wrote in most of the cases when we have a triangular mesh, and we can use the mesh op function provided by MaxScript. But in cases when we don't actually have a triangular mesh and probably have only 3 positions of objects in space and want to calculate barycentric coordinates out of them without building a mesh around them, this function would be very useful. Of course, the main reason we developed it was to show how the barycentric coordinates are calculated internally in the first place. Let's take a look at the result from the barycentric coordinates when the point is outside of the face. We have coordinates 0.711 and so on, and the third coordinate corresponding to the third vertex of the face has a negative sign. Calling our own function should result in the same barycentric coordinates.